We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Very good morning, good afternoon, good night, whenever you will watch this video. So today we will start with a new chapter of basic mechanical engineering, which is properties of steam. Now in this chapter we will start with the introductory portion so that in the further chapter your concept will be cleared. So we will start with that video, which is properties of steam. So now which type of properties steam has, that if you want to study, so over here I will write first of all properties. Over here different types of steams I will write. First one I will write saturated liquid. Then next I will write wet steam. Then I will write saturated vapor, and lastly I will write superheated steam. Now over here, as I wrote 4 types of these steams. First steam is your saturated liquid, the next is a wet steam, next is a saturated vapor, and last one is superheated steam. So these are the 4 types of the steam, and we want to discuss the properties of that steam, as the name of that chapter is properties of steam. So over here we will write different properties of steam, and for saturated liquid, for wet steam, for saturated vapor, and for superheated steam, that properties behave in which manner, that we will discuss. Now before starting this, first of all we will understand the meaning of each and every steam. So for that purpose I will draw one HS diagram or TS diagram, you can say. Over here I will draw one saturation curve. Now saturation curve means what? That it is such a curve which is passing through all the saturated points. That means over here so many points are there, and these points are known as which points? These points are known as saturated points. And saturation curve means what? It is a curve which will pass through all the saturated points. That means if you will consider one point over here, and if you want to know the condition of that point, so condition of that point is what? Saturated. Similar way, if you will consider one point over here, so condition of that point is what? It is saturated. Supposing if you consider one point over here, then if you want to find out its condition, so it is not saturated, it is superheated. Later we will discuss. Similar way, if you will consider one point over here, so that point is not superheated, it is your wet steam. But up till now, clear that thing. That means saturated curve means what? It is a curve which will pass through the saturated points, and if you will consider any point on the saturated curve, so condition of that point is saturated. Now supposing that is your peak point. Peak point means what? Maximum position of that curve. So from the peak point to the left hand side on the curve, so that is your peak point from the left hand side of the curve, peak point to the left hand side of the curve. Whatever region is there on the curve, that region is known as the saturated liquid region. Saturated liquid region means what? From the peak point to the left hand side, that is known as saturated liquid region on the curve. That means if you will consider any point, supposing that point I have considered, on saturated liquid region. So condition of that point is what? Saturated liquid. Now saturated liquid means what? That in saturated liquid, pure liquid particles are there, no vapor particles are present. Supposing from the peak point to the left hand side over here, supposing I have considered one point, so its condition is what? Saturated, but more precisely that point is present on saturated liquid region, so that is why we will get saturated liquid. Saturated liquid means what? Pure liquid particles, no vapor particles. That means on the left hand side of the curve, each and every point is present in the form of liquid, no vapor particles. So clear about the meaning of saturated liquid. Saturated liquid means what? Pure liquid particles, no vapor particles, which are present from the peak point to the left hand side on the curve. Now from the peak point to the right hand side on the curve, from the peak point to the right hand side of the curve, whatever region is present, region means what? Area, you can consider like this. So from the peak point to the right hand side on the curve, whatever region is there, that region is known as saturated vapor region. That region is known as saturated vapor region. So supposing if you will consider one point over here, at that point you are considering on saturated vapor region. So condition of that point is what? First of all, it is saturated, but as that point is considered on saturated vapor region, so condition of that point is saturated vapor. Saturated vapor means what? Pure vapor, no liquid. That means condition will be pure vapor, no liquid. Similar way here, if I will consider one point, that point I am considering from the peak point to the right hand side on the curve, and from the peak point to the right hand side on the curve, which region is present? Saturated vapor region is present. So condition of that point is what? Saturated vapor means pure vapor particles, no liquid particles. That means from the peak point to the right hand side of the curve, anywhere if you will consider the point, so its condition will be what? Pure vapor. That is the meaning of saturated vapor. So saturated vapor means what? That in saturated vapor we will get pure vapor particles, no liquid particles. Now next region is which one? Region number 3, that area which is covered by that diagram. So how much area that diagram is covering? I will say that much area that diagram is covering. So the area which is covered by that diagram is known as wet region, and in wet region what we will get? We will get wet steam. So in the wet region we will get the wet steam. So that is your wet steam. Now wet steam means what? It is a mixture of liquid plus vapor particles. That means on the left hand side liquid, on the right hand side vapor, and between liquid and vapor wet steam. That means wet steam means what? It is a mixture of liquid plus vapor particle. As for example, supposing one point if I will consider over here, so condition of that point is what? First of all, that point you are considering in wet region, so that is why that point is wet steam. On that point, condition of that steam is wet steam, and wet steam means what? It is a mixture of liquid plus vapor particles. So clear about this wet steam also. Wet steam means what? It is a mixture of liquid and vapor particles. Now last region, which is above that curve, area which is present above that curve on the right hand side only. On the left hand side we are not discussing, it is not present in your syllabus. So on the right hand side, whatever area is present above the saturation curve, that area is known as a superheated region. Now that means in supposing one point you will consider over here, so that point you are considering in superheated region. So condition of that point is what? It is superheated steam. Now superheated steam means what? In that superheated steam you will get pure vapor particles, no liquid particles. Similar way, saturated vapor means what? Pure vapor particles, no liquid particles, and superheated vapor means what? Pure vapor particles, no liquid particles. So difference between saturated vapor and superheated vapor is what? That the temperature of superheated vapor is very much high compared to that saturated vapor. As for example, supposing I am considering one point on the saturated vapor region, and that point having temperature as 100 degrees centigrade. Suppose over here temperature is 100 degrees centigrade. On that point you will get pure vapor, no liquid particles, and temperature is how much? 100 degrees centigrade. Now if I will consider one point in superheated region, so over here temperature will be suppose 150 degrees centigrade, and that point indicates superheated steam or superheated vapor, and that means at that point again we will get pure vapor particles, no liquid particles, but temperature of that steam is 150 degrees centigrade. So difference between saturated vapor, saturated vapor and superheated vapor is what? In both of these steams we will get pure vapor particles, but temperature of superheated vapor is higher than the saturated vapor. So that is all about the different types of the steams. Saturated liquid, pure liquid, no vapor, wet steam, liquid plus vapor mixture, saturated vapor, pure vapor particles. Superheated steam means pure vapor particles, but temperature of superheated steam is higher than the temperature of saturated vapor or saturated steam. Now after that, what we will do, we will discuss the properties. First property I will write like this, it is your dryness fraction. Now dryness fraction is indicated by capital X or small x, which one is convenient for you. Dryness fraction equation if I want to write, so it is X is equals to ms divided by ms plus mw. Ms means what? Mass of steam divided by mass of steam or vapor also you can say, plus mass of water. Now in a steam, basically two things are present. In a steam, water particles are there as well as liquid particles are also present. So steam is a mixture of water and liquid particles. Now dryness fraction means what? As for example, supposing dryness fraction of that steam, if you will multiply that equation with 100, then only you will get the answer of dryness fraction in percentage. Supposing dryness fraction of the steam is 80%. Then, or if you will not multiply, so answer will be how much? 0.8. Answer will be 0.8. So supposing dryness fraction is 80% or 0.8, we will discuss with 80%. 80%, then what does it indicate? That in a given steam, we are talking about dryness fraction of a steam. Supposing dryness fraction of steam is 80%. So in a steam, 80% of vapor particles are present, and remaining 20% of liquid or water particles are present. That is the meaning of what? Dryness fraction. So dryness fraction indicates what? That in a given steam, how much amount of vapor and how much amount of water are present in a given steam. So clear about dryness fraction also, that dryness fraction will indicate what? In a given steam, how much amount of vapor and how much amount of water particles are present. As for example, if I will say dryness fraction is 70%. So what does it mean? Dryness fraction is 70%. That means in a given steam, 70% of vapor particles are present, because over here mass of steam is written on the top side. So mass of vapor. So 70% of vapor particles are present, and remaining percentage of 30% of water particles are present. Now opposite of this, one another term is there which is known as wetness fraction. Now wetness fraction is indicated by 1 minus x or 100 minus x. If you will talk about that point decimal term, so you will write 1 minus x, and if you talk about percentage term, so 100 minus x. Clear about that? So now 1 minus x generally we are preferring, so for that purpose 0.8 we will select, or for that purpose 0.7 we will select. So if you select 0.8, so 0.8 vapor particles are present and remaining 0.2 water particles are present. So answer will be 1.0. That means 1 is the dryness, total dryness fraction, water plus vapor. So 1. So value of dryness fraction cannot be greater than 1. It is in between 0 and 1. Achha. Now wetness fraction means what? Supposing if I will say wetness fraction of this steam, wetness fraction of this steam is 0.3, or I will say wetness fraction of steam is 30%. So what does it mean? That in a given steam, 0.3 amount is present for water, and remaining 0.7 amount is present for vapor. Again answer will be 1. Clear about wetness fraction also? Wet, how much that steam is wet? Wet means how much amount of water particles are present. Dry means how much amount of steam is present. Dryness is there. So 80% vapor is present for dryness fraction, and if you will say wetness fraction of this steam is 30%. So how much steam is wet? 30% of wet steam is wet, and remaining 70% of steam is dry, or 30% water particle and remaining 70% of vapor particle, or 0.3 amount of water is present if wetness fraction of steam is given 30 or 0.3, and remaining 0.7 amount of vapor is present. So that is all about wetness fraction also, but we are focusing on the dryness fraction. So for dryness fraction, what we can do? So for dryness fraction, equation is important to remember, which is your ms divided by ms plus mw. So once again I will write the equation. So x is equals to what? ms divided by ms plus mw. Now dryness fraction for saturated liquid will be how much? Now as you know, for saturated liquid, liquid particles are present, vapor particles are not present. So over here mass of steam means vapor particle. So vapor particle means 0. Mass of steam is 0 because we are talking about saturated liquid. In saturated liquid, pure liquid particles, no vapor particles, and pure liquid particles are maximum, that means 1, or you can say 100 also, you can say like this. But as I told you, we will consider that dryness fraction is not more than 1 when you are not multiplying it with 100, or dryness fraction is not more than 100%. So over here maximum amount of dryness fraction is over here mass of water in saturated liquid is maximum 1, because in saturated liquid, what we are saying, in saturated liquid pure liquid is present, so pure water means 1. So over here 1 liquid particles are 1. Achha. Now 0 by 0 plus 1, so answer will be 0. So dryness saturated, for saturated liquid dryness fraction is always 0. Now next we will talk about the saturated vapor. So for saturated vapor, what we can say, saturated vapor means pure vapor particles. Pure vapor particles means mass of steam is maximum, which is 1. Mass of steam is maximum, which is 1, and no liquid particles. No liquid particles means 0. So 1 by 1 cancel, 1 answer will be there. So the dryness fraction for saturated vapor is always 1. Now we will talk about the wet steam. So over here dryness fraction answer is on this left hand side, answer is 0, 0, 0, 0, 0, and on the right hand side dryness fraction answer is 1, 1, 1, 1, 1. And dryness fraction for wet steam, that means over here value of x will be how much? It is present in between 0 and 1. Wetness, wet steam has dryness fraction which is not less than 0, and not greater than 1. From the diagram you can see. So value of x is lying between 0 and 1. That means this equation restrict one condition, which one? The dryness fraction value should not be 0 or never be less than 0, never be less than 0 or never be greater than 1. Supposing if I will write wet steam dryness fraction is 0 less than or equal to x. So what does it mean? X is equals to 0 also, and if x equals to 0, and that means it is the dryness fraction of what? Saturated liquid, because for saturated liquid x equals to 0. So that means we cannot write 0 less than x, 0 less than or equals to x. Supposing if I will write x is less than or equals to 1. So what's happened? X is equals to 1 also, and x equals to 1 means it is a saturated vapor. So that is why we are writing this type of equation, that the dryness fraction value for wet steam should not be less than 0 and should not be greater than 1 for the wet steam. So dryness fraction value, if it is greater than 1, so this type of value we cannot accept, because maximum value of dryness fraction is 1 or 100%. More than that value is not acceptable. Now we will move with the superheated steam. Superheated steam means what? Area above that curve. So for superheated steam, dryness fraction value will be how much? But obvious, over here on the right hand side, if you will consider any point, so that will be your saturated vapor, and for saturated vapor, dryness fraction value is 1, and for superheated vapor, its dryness fraction value is greater than 1, and greater than 1 value we cannot accept. So we can say like that, for superheated region, dryness fraction value is not applicable, or for superheated steam, dryness fraction value is not present. So this first line is very much important for your numerical purpose, that dryness fraction means what? It is the it will indicate what? How much amount of water and how much amount of vapor particles which are present in a given steam. Wetness fraction is indicated by 1 minus x. Wetness fraction is 30%. So what you will indicate? That 30% of water particles are present and remaining 70% of liquid particles are present. Dryness fraction for saturated liquid is always 0. I have explained. Dryness fraction for saturated vapor is always 1, and dryness fraction value for the wet steam, which is having a mixture of liquid plus vapor, is lying in between 0 and 1, and for superheated steam it is not applicable. So that is about the first property. Now we'll talk about the next property, which is your enthalpy, indicated by H, and its unit is kilojoule per kg. Over here it is unitless. If you want to multiply it with 100, then you can say it is in percentage, but right now we are not multiplying dryness fraction. In your examination, examiner will say dryness fraction value is 70%. So in the numerical you should not take the value of 70%, you should take the value of 0.7. In each and every numericals you have to take the value of dryness fraction in decimal. As for example 80% dryness fraction value is given, so you should use 0.8 for the correct answer. Now next we will go for the enthalpy. Now enthalpy means what? That already you know in your first chapter, that definition is present. That enthalpy is what? That it is the amount of the heat which is rejected by the complete combustion of unit mass. Supposing one unit mass is there, unit mass is means what? Whose mass is 1 kg. That is the unit mass. 2D unit mass if you ignite. So due to that ignition, combustion is taken place, and due to the combustion, whatever amount of the heat which is rejected by the unit mass, that amount of the heat is known as enthalpy. I am not going in detail for enthalpy. Now next is what? That for saturated liquid enthalpy is what? For saturated liquid enthalpy is HF. H means enthalpy, F means fluid. Fluid means what? One type of liquid. Saturated liquid, HF. Now later you will realize what is HF, what is HFG, what is HF plus X SFG. Each and everything fundamentals will be clear. But right now remember this thing, because in this chapter you have to use one steam table also. So over here I will write steam table. In steam table, this type of symbols you will get HF. Then over here you will get Hg, then over here you will get HF plus X HFG. Each and everything you will get from this steam table. For that I will prepare a new video. Now for saturated liquid its enthalpy is HF. Enthalpy of fluid means for liquid. For saturated vapor it is enthalpy of gas. Why gas? Because it is in the form of vapor. Then for wet steam enthalpy is HF plus X HFG. That equation you have to remember. Now if you don't want to remember this type of equation, so I will draw the graph like this over here. And that is only for your knowledge. HS diagram, in which supposing I will consider one constant pressure line. Supposing that is your constant pressure line, that you know very well now. The constant pressure line is indicated in the manner of zigzag when you are indicating it on HS diagram. Now supposing over here if I want to find out the enthalpy, so that enthalpy how I will find? That point is present on which region? Saturated liquid region. And for saturated liquid region enthalpy is HF. That point is present on saturated vapor region, so enthalpy is Hg. Now if I will consider one point over here, supposing one point over here if I will consider, which is not exactly present at the center of the graph, so over here enthalpy will be how much? So I can say like this, from 0 to HF, that distance you know, that distance is what on that point? That distance is what? HF. Plus that much distance you have to cover, and in this area, wet area, mixture of what? Mixture of water and vapor. Mixture of water and vapor. So can I write HFG? HFG means what? Mixture of fluid and gas, mixture of water and vapor. But how much water and how much vapor is present in a given steam, that is decided by what? That is decided by dryness fraction. So multiply it with X. So on that point particular X is there, over here some X is there, over here, over here, over here, over here, value of X are different. Why? Because X will indicate what? How much amount of vapor particles are present. So over here liquid particles are present. So if you will go over here on that point, so over here dryness fraction value will be 10 suppose, because vapor particles are increasing, then 20, 30, 40, 50, 60 on that point, dryness fraction is 60, over here 70, 80, 90, and over here 100%. That means value of X will be 1 for what? For saturated vapor. So value of X is 1 for saturated vapor. So on this point, that much distance HF plus whatever dryness fraction is there, X, multiply with on that point vapor and liquid both are present, so HFG. Like this also you can remember, or directly you will remember this equation. Now next we will go for superheated steam. So what is the enthalpy for superheated steam? So it is your Hg plus Cps T superheated minus T saturated. Hg plus Cps, T superheated minus T saturated. Now how you will write like this, Hg plus Cps minus T superheated, like this, that type of equation. This equation you have to remember properly. Now for that also this type of thing is there, that means you are considering your point over here. So Hg, so you know that much, from 0 to that distance you know Hg. Then Cp delta T, Cp delta T. Now Cp delta T means what? mCp delta T. Q is equals to mc delta T, that you know. Over here you can write mass of steam also if you want to write. Over here mass of steam into Cp of steam into superheated minus saturated. So on this point what's happened, supposing over here 100 degree centigrade is there and over here 150 degree centigrade is there. Over here vapor, over here vapor. That means between 100 and 150 you are supplying which heat? You are supplying specific heat, and specific heat equation is what? mc delta T. So mass of steam, Cp of steam. Why? Cp we are considering specific heat at constant pressure, because that point you are considering on a constant pressure line. And delta T means what? On this point temperature is what? Saturated temperature, and over here temperature is what? Superheated temperature. Superheated temperature is higher than saturated temperature. So mass of steam, Cp of steam, T superheated minus T saturated. In this manner also you can remember. Now after that, next property I will go with the entropy. So entropy portion also you have seen in your first chapter, whose unit is kilojoule per kg Kelvin. So I will not go in detail for this. It is the measurement of disorderness. Simply you will replace H in terms of S. So SF plus X, SFG, that is your Sg. Over here difference is there, it is your mathematical difference, and over here log difference is there. How? That Sg plus Cps ln T superheated by T saturated. Over here log difference, over here mathematical difference. After that, last one if I want to discuss the property, that is your specific volume. Specific volume is denoted by small v. Remember that, whose value unit is meter cube per kg. That means that much meter cube volume is present in 1 kg. Over here saturated liquid, it is Vf. Saturated vapor, it is Vg. And over here it is your mixture of fluid, liquid and vapor. But how much? Up to x time. That means it has some liquid particle, it has some vapor particle. So x into Vg, sorry, x into Vg, x into Vg, not Vfg. That means on this curve over here, volume on over here, suppose I will consider point over here. So if I want to consider point over here, so that is your reference Vg. But Vg means what? Dryness fraction is 1. Dryness fraction is 1 means saturated vapor. But over here dryness fraction is x. So x multiply with Vg. So this type of answer you will get. And finally for superheated steam, if you want to find out the volume, so that is very simple. First of all, we will draw this type of diagram. Over here one point is there, over here one point is there. We want which volume? We want superheated volume. So over here I will write V superheated is equals to what? That line, suppose point 1, point 2. That process 1 to 2 represent which process? Constant pressure process. And for constant pressure process, equation is what? V by T equals to C. Now on point 1 it is saturated. So can I write V saturated and by T saturated is equals to on point 2 it is V superheated by T superheated. You want V superheated volume, so V superheated will be what? V saturated by T saturated multiply with T superheated. So that much equations are very much important to remember. This is the basic of properties of steam. Without this you cannot proceed further. These are the basic and important equations. When you will we will start with the numericals, at that time this whole table must be remembered by you. So that is all about the properties, which type of properties are there and how it varies. So this table you have to remember properly for the further explanation. Now I would like to end this video. Now we'll meet with a new video. Till then, read hard, work hard. Thank you very much.